Now this is a figure in which there is a big triangle and the base of the triangle is divided into 2, 3, 4, 5 or 6, 7 number of parts. Now first, for understanding purpose, I am going to take up only two parts of the base. So there is a point here and this vertex is joined to this point, and now we have to count the number of triangles in this figure. Obviously, the number of triangles here are 1, 2 and the large one 3 triangles. So how do we generalize this when these lines are more than 1? Now see the rule which we have to follow to count the number of triangles in such a case. See, this is the base which is divided into 1 and 2 parts. So what do you do to count the number of triangles without actually counting the triangles? Just add these numbers, you will get the total number of triangles in the figure. Yes, it is as simple as that. But remember students, this shortcut can be used only in this kind of figure only. So let's have one more figure of this kind. Now this time, this triangle is divided into 3 parts and the vertex is joined with these 2 points on the base. And now we need to know how many triangles are there in this figure. So you see the base, this is the first part, the second part and the third part. So 3 parts of the base. Just add them, you get the total number of triangles as 6. You can verify also. 1, 2, 3. Then if you combine 2 triangles, this is the fourth one, this is the fifth one, and the largest triangle, that is the sixth triangle. Let's divide the base into greater number of parts. So here we have a figure in which I am dividing the base into 4 parts. So see 1, 2, 3 and 4 parts. So add the numbers, you get 10 as the total number of triangles in this figure. Friends, you can generalize this method now and try as many figures as you want. You can verify by counting the triangles actually whether you are getting correct answer or not. So in this case I am taking 1, 2, 3, 4, 5, 6, 7 parts of the base. Then the number of triangles formed are the sum of all these numbers. So up to 4 you get 10, 15, 21, 28 triangles in this figure. Friends, if you know how to find the sum of first and natural numbers, then things become more easier, because if you have to add numbers from 1 to 7, you have to just multiply 7 by its consecutive number and divide it by 2, you get the answer as 28. So series of natural numbers and how to find the sum of first and natural numbers n into n plus 1 by 2. This will help you further in reducing the time you consume for counting the number of triangles in such a kind of figure. So the first figure which I am taking is having a triangle whose base is divided into 2 parts by a line joining the vertex to this point, and there is a line parallel to the base which divides this line into 2 parts. Now these kind of figures can be very common in competitive exams, and now you will be amazed to see how we can count the number of triangles in this figure in just 3 seconds time, and that too without actually counting the triangles. How do we do this? Now the first step is to see in how many parts the base is divided. This is the first part. this is the second part. Just name the base, first part, second part, and then add the numbers which you have written on the base to get a number which is the sum of these two numbers. And now just see this side, how many parts are there? 2. Or this side, how many parts are there? 2. So the number of parts on this side is 2. So multiply this sum by 2, you get the number of triangles in this figure as 6. You can just verify. This is the first small triangle, another small triangle. Then if you take left side, this is the third triangle, this is the fourth triangle, and now combine these two. This is the fifth one, and the large one is the sixth one. So you don't need to actually count the number of triangles, and you will get the exact number of triangles which are there in this figure. Now let us generalize this and make it little bit more complicated. What happens when we have a triangle in which the base is divided into 3 parts using these lines, and there is a parallel line like this. Now name the parts of the base 1, 2 and 3 and add the numbers, you get 6. And on this side you have 2 parts, so just multiply by 2, you will get your final answer as 12 triangles. You can actually count the triangles and see your answer will never be wrong. Let's have one more figure. This time we have the base divided into 4 parts like this by using these lines, and we have 2 parallel lines like this. Now the things become little bit serious. Why? Because there are a number of triangles in this figure and actual counting will not help you here. So use the shortcut 1, 2, 3 and 4. So add, you get 10. And how many parts are there on this part? 1, 2 and 3 parts. So 10 into 3, you have 30 triangles as the answer for this figure. Likewise, you can complicate this figure because you don't get easy ones in exam. See, first part, second part, third part, fourth part, fifth part, sixth and seventh part, and you have 1, 2 and 3 parallel lines. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Sum of us 7 natural numbers. 7 into 8 by 2, that is 56 by 2, 28. And how many parts on this side? 1, 2, 3 and 4 parts. So 28 into 4, you get your final answer as 112. In this figure, you can see that the base is divided into a number of parts along with some more parallel lines to the base. Now this complicates the matter. If you start counting triangles, then you are bound to overlap or you are bound to leave some triangles. But having this shortcut up your sleeves will give you the exact answer within 4 to 5 seconds only. Now the trick to solve this kind of problem, just see there is the base which has been divided into 1, 2, 3, 4 parts. So just add these numbers, you get 10. And now you have another base which is parallel to this base. Name this also 1, 2, 3. Add these also, you get 6. If you have another base, name the parts of this also and add 1 plus 2, you get 3. Finally, add all the sums which you have got. This is 10 plus 3, 13 plus 6, 19 triangles is the exact answer of this figure. See, we have counted the number of triangles without actually counting any triangle. So this is the beauty of shortcuts. Let's have one more figure. Here we have complicated the problem little bit more. Now we have the base which has been divided into 1, 2, 3, 4, 5, 6, 7 parts, and we have 3 more bases. So we need to have 4 numbers first. Just name the parts of the first base 1, 2 and 3. 1 plus 2 plus 3 gives you 6. 1, 2. 1 plus 2 gives you 3. 1, 2, 3, 4, 5. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. And finally 1, 2, 3, 4, 5, 6, 7. So up to here it is 15. So 15 plus 6, 21. Plus 7, 28. Now you can add all the numbers. 28 plus 3, 31. Plus 6, 37. And 15, you get 52 triangles in this figure. Now this is a particular kind of figure, diamond shaped figure, in which there is a base, and across the base the two parts are nearly symmetrical, or they may not be symmetrical, but having equal number of lines drawn from the vertices which divides the base. So common base is divided into 1, 2, 3, 4 parts here, and we need to count how many triangles are there in this figure. Now this can be done without actually counting the triangles. We must understand here that the line in the center, this line is a straight line. If this is a straight line, then method is different, and if this is not a straight line, this meets the vertex at a different point and this meets at a different point, then the method is different. So be very careful to apply the method only in cases where we have a straight line dividing this entire figure into two parts. So this is a straight line here. Now in such cases, what do we do? The first thing is to we forget the lower part of this figure and start counting the number of parts into which the base is divided. So the base is divided here in 4 parts. So what we do is to add 1 plus 2 plus 3 plus 4, we get 10. So if we had only figure which is above the base, we would have got 10 triangles. But we have same kind of figure under the top figure also. So there will be equal number of triangles under the base also. So we have to multiply this by 2. Now we get 20 triangles. But we have not considered here that we can combine these two triangles and get another triangle here. So whenever this is a straight line, then there are more triangles to be counted. But if this was not a straight line, then your answer would have been 20. Now, how many more triangles can be formed? That can be found out by just adding the highest number, that is 4. So how many parts of the base are made? 4 parts. So just add 4 triangles, you get 24 triangles as the answer of this question. Isn't that amazing, friends? A small method and you come to the answer without actually counting any triangle in this figure. Now you can verify, you can try and count the number of triangles in this. I am sure you will get the answer of 24 triangles. Let us generalize this in this question. Now the base has been divided into greater number of parts. So see how many parts? 1, 2, 3, 4, 5 and 6. So if you add 1 plus 2 plus 3 plus 4 plus 5 plus 6, students who are aware of sum of first and natural numbers, they will come to know immediately that the answer is 21. So 1 to 4 it is 10, 15, 21. Now 21 triangles on the top, multiplied by 2, double it, you get 42 triangles, and you have to add 1, 2, 3, 4, 5, 6, 6. That is the highest number is 6. So just add 6. You get 48 triangles as the answer of this figure. Now see, observe this figure that a large triangle has been divided into smaller triangles by drawing lines parallel to the base. Here also you can see a large number of triangles in this figure. Now whenever you come across these kind of figures, first thing you have to observe is in how many parts the base is divided. Now see, in this case the base is divided into two parts, and in this case the base is divided into four parts. So I am taking up this shortcut to tell you a method through which you can count the number of triangles in this figure without counting the triangles, and this is for even number of parts of the base. So this shortcut 5 is when n is even. Now what is n? N is the number of parts of base. 1, 2, so n is even, so n is 2 in this case, and n is 4 in this case. So here n is 2 and here n is 4. Now the shortcut which you have to apply to come directly to the answer as to how many triangles are contained in this figure is, now this is the shortcut, number of triangles is 1/8 of n multiplied by 2 more than n and multiplied by double of n plus 1. Very interesting shortcut, and now you can test this shortcut for n equal to 2 and n equal to 4. Now in this case, when n equal to 2, then number of triangles is 1/8 of n is 2, so 2 plus 2 4, double of 2 is 2 into 2 4 plus 1 5, so 1/8 of 5 4s are 20 into 2 40, so 40 by 8 is 5. So your answer for the first figure is 5 triangles. Now you can see very easily 1, 2, 3, 4 and the last triangle 5. Students, I have taken up the preliminary example of n equal to 2 just to make you understand about the shortcut which we are using. You can test this shortcut for greater number of parts of the base. Let us check for n equal to 4. You get 1/8 of n equal to 4. So 4 plus 2 is 6. Double of 4 is 8 plus 1 9. So 4 cancels 2 times and 2 cancels 3 times. So here you have 9 3s are 27 triangles in the figure which is given here. And if you start counting the triangle, counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm sure you are going to miss out on 1 or 2 triangles, surely. Figure. Now as you can see, there are 2 figures given here, and we have to tell how many triangles are contained in these figures. Now if you start counting the number of triangles right from 1, 2, 3, 4, then it is going to complicate things and consume a lot of time. Now this trick will give you a shortcut through which you will be counting the total number of triangles in this figure without actually counting the triangles. Yes, without actually counting the triangles. In my previous shortcut, I took up similar kind of figures in which the base was divided into even number of parts. And this time the base is divided into odd number of parts. See, 3 parts of the base here. And if you see this figure, 1, 2, 3, 4 and 5. So 5 parts. So odd number of parts. So number of parts of the base is odd in this case. What is n? It is the number of parts of base. Now in such cases, you can use this shortcut to find the number of triangles. It is 1/8 of n. N is the number of parts of the base. multiplied by n plus 2 multiplied by double n plus 2 plus 1 and just subtract 1 from this product. Remember, this 1 is inside the bracket, the square brackets, and not outside, it is inside. So in this case n equal to 3, so you can just substitute n equal to 3. So this becomes 3, 3 plus 2 5, and if you put 3 here, 3 to the 6 plus 1 7 minus 1. So you get an odd number here, which you reduce by 1, you get an even number. So this is 1/8 of 5 3 is 15, 15 into 7 is 105, so minus 1 104, and when you divide this you get the exact number of triangles as 13. So 13 triangles is the answer to the first figure. Likewise, you can generalize this and put n equal to 5 here. See, the base is divided into 5 parts. So 1/8 of, put 5, 5, 5 plus 2, 7, and 5 to the 10 plus 1, 11, minus 1. So you get 1/8 of, this is 35, 35 into 11 is 385, minus 1. So 1/8 of 384. So the answer you get is 8 4s are 32, 64. So 8 8s are 64. So 48 triangles is the answer to the second figure. So students, you see, knowledge of a shortcut, and you can count the number of triangles in a given figure without actually counting the triangles. So if you like the video, share it and subscribe the channel.